Operational amplifier. Operational amplifier and its characteristics. Characteristic parameters. Ah, Simply consider op-amps. Simply consider op-amps. Yeah. Okay. The operational amplifier. Note down. The operational amplifier is a device. The operational amplifier is a device with differential amplifier. Not difference voltage type. Differential amplifier at the input and a single-ended output has a large differential voltage gain. And a single-ended output has a large differential voltage gain. This gain is between differential input and the output of operational amplifier. Input and output of the operational amplifier. This common mode gain will be extremely small. Okay, right. Here, operational amplifiers classified into two types. Operational amplifier classified into two types. One is inverting operational amplifier. Second one is non-inverting operational amplifier. Inverting operational amplifier. Second one, non-inverting operational amplifier. Inverting operational amplifier. Circuit diagram. IC pin number, integrated circuit 741. IC, integrated circuit 741, which is called as positive, this is a negative. When operation amplifier positive terminal connected to earth, but ground, which is connected to input. This kind of amplifier is called as a inverting operational amplifier. Next, second one, non-inverting operational amplifier. If in case of negative terminal is connected to ground and positive connected to input. Here negative connected to input. Again, it is also same thing. IC 741. This is a non-inverting. This is output terminal. Non-inverting operational amplifier. Operational amplifier. Okay. If this input is a 1 is, you can feel V1, otherwise you can feel V2. Simply operation amplifier circuit diagram is inverter and inverter. Commonly operation amplifier assembly, these are the two input terminals. One is this is a positive, one is positive, one is negative. This is a 740 or IC number. One thing is V1 you can say, other one is you can say V2. Then the difference VD is equal to higher minus smaller V1 variation V2. The difference in volt. Okay, no? Note. Operation amplifier type of amplifiers inverting inverting amplifier, non-inverting operational amplifier. Input to output things. Instead of that, you can take a basic block diagram. Instead of the triangle symbol, you can take box. That box you can say the operational amplifier. Voltage in, voltage out. Basic block diagram of operational amplifier. Then here is a input. This is the output. Here thing is a V in. Here thing is a V out. This thing is a operational amplifier gain. Operational amplifier gain or amplifier gain. That is a voltage gain EV. Current gain alpha or beta or gamma. Power gain AP. So gain, voltage gain nothing but here AV voltage gain is equal to ratio of the voltage, output voltage to input voltage. V out by V in is called as a voltage gain. Okay, na? If in case of the positive, sorry, that output is connection giving to input, nothing but feedback to input. That is called as a feedback operational amplifier. Maybe that feedback it can positive or maybe the feedback is negative. Okay, feedback operation amplifier two kinds. One is a positive feedback operation amplifier. Second one is a negative feedback operational amplifier. It means output pulse connected to feedback, output pulse feed giving back to input. And output connection the input connection give it. That's the feedback. One is a positive, other one is a negative type. Yeah. Operational feedback. This one is a operational feedback. We'll see now derivation part. Operational feedback. In that operational feedback, first I can assume inverting operational amplifier. Operational feedback. Operational feedback. Yeah. One input terminal, other input terminal. For this input terminal, he is connected as a input resistance. You can extend this part. Input voltage V in. Output voltage V out. Voltage always measuring between 2 points. One is a here high positive one, a negative purpose. You can take the ground. Between these two pins, you can find out voltage. Okay, na? Next, feedback giving to input. This is a feedback resistance, RF. Feedback resistance. Here, input current across the input resistance that is called as the I in, input current. Here input voltage between the two terminals is assumed as a Vs. The next current across the RF, that is a feedback current is a RF. Feedback current is a RF.
Yes.
All right. Right. Now you can find out the equations from here. Negative voltage feedback is produced by the resistor RF connected between the input and output terminals. Negative because of phase inversion in the amplifier is in out of state, nothing but opposite directions. It is convenient to analyze operational feedback circuit by applying Kirchhoff's second law. I think you know Kirchhoff first law, Kirchhoff second law. Kirchhoff first law is called as a Kirchhoff current law simply. Kirchhoff second law is but voltage law. Kirchhoff first law at a junction, at any junction in electric circuit, sum of current entering to the junction equal sum of current leaving to the junction. You can consider any junction. Entering sum of entering current equal sum of leaving to the junction current. That is the first law. Second law, voltage law. We can consider any loop. In that loop or mesh, the potential difference across the all components equal to 0. Potential difference across the all components equal to 0. That is called as a Kirchhoff second law. First law, current law. Second law, voltage law. Here the saying applying Kirchhoff current law or rule to the branch point S. To the branch point S. So he considering at this point, at this junction, he named as a S. At this junction, you can observe current entering into the junction is a I in. Current leaving to the junction is a IF. At a junction, yes, applying KCL, applying KCL, Kirchhoff current law. Entering current equal to leaving current. That is called as a I in equal to IF. F is a feedback current. According to Ohm's law, V is equal to IR. V equal to IR. From that, I is equal to, can I write V by R? If in case of voltage varying between 2 points, we can take delta V by R. So from that, I is equal to delta V by R. Delta V, here input initial point is a V in minus Vs. So I can written as V in minus Vs. By resistance is a input resistance na? R in or else Ri. Both are same meaning. V in minus Vs by R in equal to IF across this thing. Between these two junctions or between these 2 points, I is equal to V by R. Okay. Next, between these 2 points, that is a Vs minus V naught by RF. Vs minus V naught by RF. Okay. We know that voltage gain. We know that AV, voltage gain, equal to output voltage by input voltage. If you consider negative feedback, then we'll get a sign is a minus. V naught by V in. Now you can eliminate your V naught value or else Vs value. Then you can take equation in terms of V out and V in. Then better you can eliminate Vs. For operation amplifier, output is a V naught. Input is a here Vs. Then here it can be written as, instead of V in, input is a Vs. So from this it can written as Vs is equal to minus V naught by AV. This value can substitute here. So that implies modified equation. Instead of V in only, V in minus, instead of Vs, minus of minus, we'll get plus V naught by AV. Vs is equal to minus of minus plus V naught by AV by Rin equal to Vs value minus V naught by AV equal to minus V naught by Rf. From that you can say V naught is equal to something. V naught is equal to something. You can take here common V naught. Oh, better you can do the cross multiplication. Is there any possibility? V naught is equal to Rf by R naught into something value in exponential. Better you can take V out or V naught is common. Then you can written as V in by R in. You can send other side minus V naught by AV into Rf minus V naught by Rf. At the is minus V naught by AV into Rin. Now you can take V naught common. V first I'm taking right side value. V naught common తీసుకుంటప్పుడు వస్తుంది 1 by AV into Rf plus 1 by AV into Rin plus 1 by Rf. Whole thing equal to V in by Rin. V in by Rin. మనకు కావాల్సింది V naught వాల్యూ. అంటే ఇక్కడ కూడా Rf ని కామన్ తీసేటట్టు చేసుకోవాలి. అప్పుడు ఇక్కడ Rf కామన్ తీస్తే విల్ గెట్ Rf క్యాన్సల్. ఇక్కడ ఏంటంటే Rf తో మల్టిప్లై చేయాల్సి వస్తున్నప్పుడు ఇక్కడ Rf వెళ్ళిపోతుంది. ఇది 1 అయిపోతుందా? You can do the cross multiplication. That implies V naught is equal minus Rf by Rin into V in divided by 1 plus 1 by AV plus Rf by AV into Rin. V out is it. Okay, na? If gain is nothing but AV, if gain is very large, the denominator value will be go very high, then automatically 1 by AV goes to 0 and RF by AV into RN also goes to 0. Then we'll get V naught is equal to minus RF by RN into V in. When if it is goes to gain is very large. If gain AV is equal to very large, V naught is equal to minus RF by RN into V in. Note down. Okay, na? No doubt. After this, next one for this one attached SAQ. That is a virtual ground. Virtual ground. The branch point S has a special significance in operational amplifier. This is special operational amplifier. This may be explained by determining the effective impedance between S and ground. Between S and ground, which is given by the ratio of Vs to the input current. Zs is equal to Vs by I in is equal to In value Vs minus V naught by Rf. Nothing but I is equal to V by R, delta V by R. That value you can substitute, you will get Zs is equal to Rf by 1 plus A. Nothing but A is a voltage gain. Output voltage by input voltage. That is nothing but V naught by Vs. You can expect for this much in the 5 markers. They'll ask, explain virtual ground in operational amplifier. Okay, na? That much is enough. Next, one more important SAQ, means 5 mark question. Distinguish between ideal operational amplifier and practical operational amplifier. These points also you can expect in 5 marks. This one, operational feedback amplifier explanation, 10 marks. Virtual ground and characteristics between ideal operational amplifier and practical operational amplifier, 5 marks. Or else sometime they'll ask, only write down few characteristics points about the ideal operational amplifier. They'll ask like that also. And ఏ ఒకదానైనా అడగొచ్చు, లేదా ప్రాక్టికల్ ఆపరేషన్ యాంప్లిఫైర్ ఆర్ ఎల్స్ ఐడియల్ ఆపరేషనల్ యాంప్లిఫైర్. యా, ఐడియల్ అంటే ఆల్రెడీ వినో సార్, ఐడియల్ పర్సన్ జనరల్ వీ కెన్ కాల్ అంటే నో నెగిటివ్ థాట్స్, అంటే అపోజిట్ థింగ్ తక్కువ ఉంటుంది అనేసి అంత పాజిటివ్ రిసీవ్ చేసుకుంటాం. సో ఐడియల్ ఆపరేషన్ యాంప్లిఫైర్ ఇట్స్ ఇంటర్నల్ resistance offered by themselves is zero. That is nothing but he is saying input impedance is infinite. No current flows to it. Ideal operation amplifier. Okay. Second point. Output impedance is zero. Output impedance is zero, unaffected by the load. The range value is also given. Resistance values. Voltage gain is infinite. Voltage gain also is infinite. Bandwidth is infinite, no phase change with frequency or constant gain. Next point, output voltage is zero when Vi is equal to V1 equal to V2. Characteristics do not drift with temperature. Okay? Yes. Next one, operational parameters and specifications. Yeah, it is also very, very important in 10 markers. In that one, offset current. Next, CMRR, common mode rejection ratio. It is a important things. Sleeve rate. And next, the thing is explanation part. Okay, this question also important. So compared to this operational feedback, operational amplifier parameters and specifications, they can mention clearly sometime. Offset current, offset voltage, or CMRR, common mode rejection ratio. Next, slew rate. ఈ 4 points గురించి అడగొచ్చు. Sometimes they can ask only any two, sometimes they can ask any three or any all fours. They will ask like that. We'll do the derivation part. Give 1 second. We'll go to next point. In that one, offset currents, offset voltage, CMRR, operation amplifier parameters, and its specifications. Okay. Ideal operational amplifier gives zero output when the input voltage is zero. But the practical operational amplifier behaves differently. The exhibit an imbalance caused by the mismatch of the output transistors and components. We'll take now a graph between input voltage and output voltage. So for that one, first we'll take graph. We'll discuss. One line is passing through origin from negative to positive axis. This you can see A, this is a B, this is C curve. Yeah. V, O, S here. This value is a B width. Now you can take same width B here. This is the origin O. VOS positive value. Here VOS negative. Okay. The characteristics curve of practical operational amplifier make the graph between input voltage and output voltage for different slope of curves. Curve A, curve B, curve C having with the different slopes. In either case, the curve does not pass to the origin in B and C cases. Only the curve A line is passing through the origin. Okay. Yeah. The output voltage VOS, which would have to applied in order to obtain zero output voltage, is called input offset voltage. Okay. To make output voltage zero, we have to give the equal voltage in output and input conditions. For that one, you can consider as inverting operational amplifier with feedback resistance. So for that one, you can take inverting operational amplifier plus so minus so this plus is connected to ground. This is a input resistance R in, this is terminal, one is a V1, other one is a V like that. This is a, you can give this V in, input voltage, and which is connected to feedback resistance here RF. Feedback resistance is RF. Right? This is IC number 741. Offset current. Two ends of the potentiometer are connected, and the positive one thing and negative one thing is this, like this connection is. In that one point was, first one is the offset current, next one is the offset voltage, the next CMRR. First we will go to first heading offset current. An operational amplifier whose input transistor have equal voltage value in operational amplifier. The input offset voltage is zero. The input offset voltage is zero. The base current of input transistors are never equal because the current gains sorry for this. Yes. So for that one offset current purpose, we have to take the input current relations with the voltage. One terminal is a IB1, other one terminal is a IB2. Current across this base thing is input terminal, other one is a second terminal. The voltage appears at inverting input. Inverting input. Non-inverting input is when the ground is connected to negative, then you can say the non-inverting input. Inverting input, when positive is connected, this input is called as a positive is connected to ground, and this input is called as a inverting input. This inverting input you can say here V1. This inverting, this non-inverting input you can say the V2. Inverting input voltage V is equal to IR. IR. I is a base current in across the first terminal. IB1 we can call. This is I can call current, and this one is the IB2. V equal to IR. R is a resistance, that is a base resistance, nothing but input resistance. Same thing here. In the non-inverting input, V2 is equal to IB2 into RB. ఇదంతా సోది కాకుండా దీన్ని వన్ పిన్ అనుకొని దీన్ని సెకండ్ పిన్ అనుకుంటే వోల్టేజ్ అక్రాస్ ద ఫస్ట్ పిన్, వోల్టేజ్ అక్రాస్ సెకండ్ పిన్. V1 is equal to IB1 RB, V2 is equal to IB2 R2 RB. V is equal to IR type. V is equal to IR. Am I clear? V is equal to Yeah, the voltage difference between the two, and that is called as a V1 minus V2. Then delta V, nothing but V in, delta V in equal to, you can say, the V1 minus V2. Then delta V is equal to V1 value IB1 into IB1 minus IB2 into RB. If you want to say the current, then I is equal to delta V by R, IB1 minus IB2, whatever may be. మనకు అక్కడ ఏది అనుకుంటే అక్కడ నుంచి దాని నుంచి వాల్యూ చెప్పొచ్చు కదా. దిస్ different current in input source, that thing it can written as this, nothing but V1 minus V2 is equal to input operational amplifier source current IB1 minus IB2. So from that I can written as IOS. Okay, na? That is called as a offset current in the input terminals. Offset, yes, I is a current. VOS, that is a voltage, sorry, offset voltage. VOS అంటేనే రఫ్ పాయింట్ రాసుకున్నాం. IOS, ఆఫ్సెట్ కరెంట్, డికోడింగ్ VOS, ఆఫ్సెట్ వోల్టేజ్. VOS is equal to V1 minus V2 by RB. ఇక్కడ మెటీరియల్ టెక్స్ట్ బుక్ ఇవ్వలేదు. ఆఫ్సెట్ వోల్టేజ్, ఒకవేళ ఆఫ్సెట్ వోల్టేజ్ అడిగినా కూడా సేమ్ థింగ్. ఇన్స్టెడ్ ఆఫ్ V1 minus V2 is equal, it can written as VOS. This is the offset current. Same thing, second point, offset voltage అని అడిగితే then it can be written as VOS is equal to IB1 minus IB2 into RB. Okay, no? This is the first point you can feel. Here you can say the second point. Similarly, offset voltage, that is a VOS is equal to IB1 minus IB2 into RB. Now clear? Yeah, like this. This is a offset current, offset voltage. Similarly, you can take next one, common mode rejection ratio, that is CMRR. Sometimes they will ask only for CMRR in the 5 markers, very rare cases, and split చేసి అడుగుతాడు. maximum లో ఏదో రెండు కాంబినేషన్ అడుగుతాడు, ఆ రెండు తీసుకుంటే అక్కడ విల్ గెట్ 10 మార్క్ ఆన్సర్. ఆఫ్సెట్ కరెంట్, ఆఫ్సెట్ వోల్టేజ్, నెక్స్ట్ CMRR, కామన్ మోడ్ రిజెక్షన్ రేషియో for operational amplifier. Yeah. CMRR, common mode rejection ratio condition. We can take operational amplifier with inverting and non-inverting, both the combinations. Based on your possibility, you can consider which is easier, that thing on. Right? Here is a input values, input voltage. One terminal 1, other terminal is 2 type. So then here V2, then it can use the ground connections. Voltage, input voltage 192. The difference in voltage V2 is equal, VD is equal to V1 minus V2, IS minus least one. Okay, it is a IC 741 operational amplifiers. Okay, right. So for that one, common voltage, nothing but average voltage type on. And but the different voltage is a V1 minus V2 or V2 minus V1, which is higher that thing on. Next, common mode input voltage. VD is equal to, you can say, V1 variation V2 and VC, that is a common mode input voltage. Common mode input voltage. Common mode input voltage. And then it can be written as VC is equal to V1 plus V2 by 2. V1 plus V2 by 2 on. From this, it can be written as if V1 is highest, then VD is equal to V1 minus V2. Then it can be written as from that V1 is equal to V1 is equal to VD minus VD plus V2. V1 is equal to VD plus V2. So it can be written as VC is equal to V1 value, VD plus V2 plus V2 by 2. We'll get the value is VC is equal to VD plus 2VD by 2 by 2. These two to get cancelled. Then we'll get a common mode input voltage. VC is equal to VD by 2. It's my bad. It is not VD. This is V2. VD by 2. VD by 2 plus V2. VD by 2 plus V2. Similarly, if you want to say from that V2 value in terms of common mode input voltage, then we can written as VC is equal to V2 is equal to VC minus VD by 2. When output is 0, in the operational amplifier output is 0, when the two input voltages are identical using superposition equivalent circuits. If values are same in the that value will be get output value will be 0 condition. So now we have to calculate in this one V naught, what output value, the input voltage only. Now we can find out V naught is equal something. We know voltage gain is equal to output voltage by input voltage. Input terminal to we can measure gain. 1 second. So V naught is equal to, before that we can go through it. Voltage gain is equal to V naught by V in, roughly thinking. From that V naught is equal to AV into V in. We can remember that point. From that point only can measure the calculations, or you can find out the equation values. Calculate the equation values. So here V naught it can measure in the two intervals. V naught is equal to, first you can take across the input and common mode input voltage ఇక్కడ వరకు, from here to here, then here to here. Across the input voltage terminals, one gain. Next, across the operational amplifier terminals, one gain. Okay na? Is it okay? Then it can be written as V naught is equal to voltage gain across the common mode, that is a AC. Voltage is a VC. Next, across the difference values AD, VD, that values you can try to see. VC is a common mode input voltage. AC is a across the input voltage and input terminals. Between these two terminals, that is voltage gain is a AC. These two terminals is voltage gain is called as a AD. Common mode rejection ratio. It is defined as the common mode rejection ratio. It is defined as the voltage gain ratio of difference voltage gain to common mode input voltage gain. Nothing but you can say here AD by AV. No, AD by AC, not AV. AD by AC. AD by AC. In that, you can say something AC is equal to AD by CMRR. This AC value you can substitute here. We can eliminate AC value. We'll get answer in terms of VC, AD, VD. So from that, output voltage V naught is equal to AD VC by CMRR plus AD VD. Better you can take AD also common. Then VC by CMRR, V naught is equal to AD into VC by CMRR plus VD. Okay na? For ideal operational amplifier, CMRR ratio value goes to large. Nothing but infinite. If that value is a large or infinite, then AD goes to, sorry, V naught goes to AD and VD only. VC by CMRR value goes to 0 only. Okay na? That is called as a CMRR. So I can say ratio of AD by AC thing is. One thing is a operational amplifier offset current and input current కనుక్కుందాం. I is equal to delta V by R. Offset voltage delta V is equal to IB1 minus IB2 into RB. That is a offset voltage. Next one CMRR. It is defined as a ratio of AD by AC. The AD value, AC value you can find out from this diagram. And you can express AD value, sorry, V naught value in terms of AD and VD VC along with the CMRR. For ideal operational amplifier, CMRR values goes to infinite. If that value goes to infinite, then VC by CMRR value equal to 0. Then we can say V naught is equal to AD into VD. Next one, slave rate. Slave rate. Operational amplifier frequency range or else current across a capacitor plate, nothing but conventional current. వినుదు. Current across the capacitor plates I is equal to C into dV by dt. From that one only you can say dV by dt is equal to I by C. The rate of change of voltage, dV by dt, it is equivalent to current divided by capacitor values. If changing of current, the capacitor value also, energy stored in the capacitor value also, it can change with different interval of time. That is, you can say in terms of equation, dV by dt is equal to I by C. Once you can observe in your material page number 141. dV by dt is equal to I by C. Okay, that is called as a slave rate. It can convert the signals one formation to another form. Analogous signals converted into ramp or square shape, some other things. This thing will use in practical operational amplifier. With the help of the slave rate, we are changing the wave formation. Sine wave 2, we can change to ramp. Ramp 2, we can change into square. Square 2, some other different wave formation. In that waveform changing purpose, we'll use the sleeve rate. Nothing but here you can say the particle vibrations per second, it can be changes with respect to the time. Even the voltage also can changes with respect to time intervals. That is the dV by dt is equal to I by C. From that it can change that frequency of the capacitor value. Okay, now in this exercise, in this unit, important questions. Difference between operational amplifier, ideal operation amplifier and practical operation amplifier, or they can have sometime only ideal operational amplifier. Ideal operational amplifier. Next question. Explain the terms offset voltage, offset current, and next CMRR, slew rate. అంటే బేసిక్గా చెప్పాలంటే అక్కడ ఉన్న త్రీ క్వశ్చన్స్ ఇంపార్టెంటే. ఆ త్రీలో ఏదో ఒకటి అడగొచ్చు. దాంట్లో ఫస్ట్ ప్రయారిటీ ఎక్స్ప్లెయిన్ ద టర్మ్స్ ఆఫ్సెట్ వోల్టేజ్, ఆఫ్సెట్ కరెంట్, సిఎంఆర్ఆర్. ఇవి బాగా రిపీట్ అవుతున్న సెంటెన్స్. యూ కెన్ ఎక్స్పెక్ట్ ఫ్రమ్ దీస్ పార్ట్స్. 4 ఒకేసారి టుగెదర్ అడిగితే మేబీ 10 మార్క్స్ అడగచ్చు. అదర్వైజ్ A1 2 అడిగితే 5 మార్క్స్ అడగచ్చు. ఇన్వర్టింగ్ ఆపరేషనల్ యాంప్లిఫైయర్ డయాగ్రామ్ వేయాలి. అక్కడ నుంచి ఏం చేస్తారు సింపుల్ గా మీరు, యూ కెన్ ఎక్స్ప్లెయిన్ కరెంట్ ఈక్వేషన్ అండ్ వోల్టేజ్ ఈక్వేషన్స్ ఇన్ టర్మ్స్ ఆఫ్ రెసిస్టర్. ఓకే, దట్స్ గుడ్. సో బేసిక్గా చెప్పాలంటే ఈ యూనిట్ లో 3 క్వశ్చన్స్ ఇంపార్టెంట్. దాంట్లో సెకండ్ వన్ మోస్ట్ ఇంపార్టెంట్. Then next we can go to next unit. Unit number 9. Next one. Once.
మాకు ఎక్స్ప్లెయిన్ చేసే అందరిలోకి ద బెస్ట్ ఎక్స్ప్లెనేషన్ అయింది.
The next one, Operational amplifier configuration. Operational amplifier configuration. Okay. Yeah. Here we know already in the previous
కాసేపు రెస్ట్
unit,
తీసుకుంటాం.
inverting operational amplifier, non-inverting operational amplifier we know. Inverting
నేను
operational
వచ్చేటప్పుడు కొన్నా ఉన్నా కదా,
amplifier.
యాక్చువల్గా మార్కెటింగ్ క్లాసులకు వాటన్నిటికి వెళ్దాం అనుకున్నా. నాకేం ఆకలి వస్తుంది, 2:30 అయింది అప్పటికి అనేసి ముందు ఇంటికి వచ్చాయి. ఇప్పుడు వెళ్ళి కొనుక్కున్నాం కదా, అది నీవు కట్టుకునేసి వెళ్ళాలి. వెళ్ళాంగా. అవును, నీ చీర అందుకే నేను కట్టుకోవట్లా. కట్టుకుంటావు అది?
One second. Operational amplifier, it can classify two types. Inverting operational amplifier, non-inverting amplifier. Inverting operational amplifier is a positive pin connected to ground. Non-inverting negative pin is connected to ground. That thing already we know. In that we have to discuss mathematical part about the inverting configuration, operational amplifier inverting configuration. We know, sir, inverting configuration and the positive terminal is connected to ground. That explanation operation part we'll discuss here. This is an important part only. They will ask the feedback gain. Beta is equal something. They will ask the derivation part. Beta is equal to, we have to find out something value. Okay, done. So first I'm taking inverting amplifier configuration. Plus or minus. Operation amplifier number is the IC741. All the cases are fixed value only. So here is a voltage gain AV. Or it can take these terminals connected into these 2 points, and which is a feedback resistance RF. This is the output. Input is a positive terminal connected to ground. Positive terminal connected to ground, which thing is a input resistance. This is called as a RF, feedback resistance. Okay. This voltage is called as a V in. This resistance is called as a R in. This current is called as a I in. The junction we know S point. Okay. The output is called as a V out. Okay. From this you can say voltage difference. VD is equal to V1 minus V2 variation. If in case of V2 is higher, then you can say VD is equal to V2 minus V1. V2 minus V1. Okay. V2 minus V1 thing is okay. Next you can calculate input resistance, nothing but impedance, right? Impedance but combination of the two component resistance is called as input resistance. No? So from that R, input resistance, V is equal to IR, I is equal to V by R. Here the thing is labeling part is important. R is equal to, we can say Vs by, then this terminal you can say this A, internal resistance R is equal to Vs by Ia current. From this you can say input current Ia is equal to Vs by R. You can assume it is a one equation, number of equations. Next thing is output resistance. Output resistance, we can say the load resistance. Load resistance always it can connected in the parallel. So this input terminal connected to this thing will get RL, load resistance nothing but R out. Output values across these 2 points. Here we'll get output B out. So from that V is equal to IR. R is equal to V by I. When which is when Vs is equal to 0. This is a output resistance, this is the input resistance, output input current, that values. We know the inverting operation amplifier gain AV is equal to minus V naught by Vs minus V naught by Vs at constant current across the load resistance. At constant current across the load resistance. You can consider this is point number 3. The next loop gain, voltage loop gain. We can assume here loop gain is equal to G is equal to minus V naught by V in. Now you can apply Kirchhoff first law at a junction S. One second, I'll filling. Apply Kirchhoff first law at a junction S. Sum of current entering to the junction is equal to sum of current leaving to the junction. Sorry. Sum of current entering to the junction is equal to sum of current leaving to the junction. So you can apply Kirchhoff current law at a junction S. So that is nothing but better you can say applying KCL, Kirchhoff current law at S, at a junction S. Actual thing is entering current you can say I in, leaving current how much, sorry, leaving current is a one thing is a but here feedback current also no. One thing is IF and conventional current across the voltage gain. Nothing but IA. For example, you can feel this is a something IA. This is you can say IF. Then IA is equal to IA plus IF, either capital letters or small letters, current magnitudes. I in is equal to if load resistance RL greater than R naught, then you can say the values. Vs value from voltage gain A is equal to minus V naught by Vs. From that you can say Vs is equal to something. Vs is equal to minus V naught by A. చూడండి అక్కడ ఇక్కడ తిప్పి రాస్తాం అక్కడ. So that Vs value can substitute here. And first you can find out II value, means what I input current value and feedback current. Input current here thing on 1 second. I in is equal to input current, input voltage minus difference in voltage V in minus Vs by R in. Next, another one you can find out feedback current across the feedback resistance. Then you can say here is a Vs, here is a V naught value. Feedback current is equal V is equal to Vs minus V naught by impedance. That is, you can take it as feedback impedance ZF. Impedance is a ZF. Z impedance ఎందుకు పడుతున్నాం అంటే ఇక్కడ కాంబినేషన్ ఆఫ్ two components opposing resistance is called as a minimum two component. That's called as a impedance. This terminology introduced in AC, alternating current. Now we know Vs value, I in value, If value. These values are substitute in I నుంచి లాక్కుందాం. In is equal to or in is equal to V in minus Vs. Vs value can substitute here. అంటే Vs ని ఎలిమినేట్ చేసి in terms of V naught to V in లో ఎక్స్ప్రెస్ చేస్తున్నాను. Understood? Then it can be written as I in is equal to V in minus instead of Vs minus of minus plus V naught by A whole divided by R in. Next one If. If is equal to Vs minus V naught. Vs value minus V naught by A minus V naught by ZF. Minus V naught by A minus V naught by ZF. And I in value, If value వచ్చాయి. So from that you can try to say IA.
Sir, I in value by Z I ఉంది కదా sir, R
1 second. I in value this I V in minus Vs by R in. So I in is equal V in minus of minus this Vs values plus V naught by A by R in. అంటే ఇన్స్టెడ్ ఆఫ్ Vs లో V in minus V naught by A సబ్స్టిట్యూషన్ ఇది I in అయిపోయింది. నెక్స్ట్ If is equal to here this is a feedback current across the RF resistance. ఈ ZF అంటే ఏంటి మీనింగ్ అంటే ఇన్స్టెడ్ ఆఫ్ RF లో ZF అని రాస్తాడు ఇక్కడ. అంటే అపోజింగ్ రెసిస్టెన్స్ ఆఫర్డ్ బై ద ఫీడ్బ్యాక్ రెసిస్టెన్స్ దట్ ఈస్ కాల్డ్ ఎస్ ఇంపిడెన్స్ అని. ఇన్స్టెడ్ ఆఫ్ ZF లో మనం RF రాసిన ఓకే ఫిక్స్డ్ రెసిస్టెన్స్ వాల్యూ ఉన్నప్పుడు సో Vs minus V naught by ZF, that is the If value. If is equal to minus V naught by A minus V naught by ZF. These two conditions okay. Now you can find out Ia value and this I in value, If value, Ia value you can substitute in that equation. Equation number ఎక్కడ వరకు అయిపోయాం. ఫర్ ఎగ్జాంపుల్ దీన్ని 4 అనుకోండి, 5 అనేది. ఈ 5 లో I in వాల్యూ, IA వాల్యూ, IF వాల్యూ. I in వాల్యూ ఇక్కడ వచ్చింది, IF వాల్యూ ఉంది. IA ఈక్వేషన్ కనుక్కొని ఆ IA, I in, IF అన్ని దాన్ని సబ్స్టిట్యూట్ చేసి వీ హ్యావ్ టు ఫైండ్ అవుట్ ఫైనల్లీ బీటా వాల్యూ కనుక్కోవాలి. బీటా ఈజ్ ఈక్వల్ టు వి నో జనరల్లీ గెయిన్. దట్ వాల్యూ వీ హ్యావ్ టు మెజర్ ఇట్. 1 సెకండ్. ఏం చేస్తే IA వాల్యూ ఎట్లా వస్తుంది చూద్దాం. voltage gain A is equal to will be no V naught by V in. So from that we can written as V naught is equal to V in equal better. V in is equal to V naught by A na. ఇక్కడ V in అంటే ఇన్పుట్ కరెంట్ ఇన్పుట్ రెసిస్టెన్స్ కదా. ఇన్పుట్ కరెంట్ IA ఇన్పుట్ రెసిస్టెన్స్ R తీసుకుంటే ఇన్స్టెడ్ ఆఫ్ R in లో ఇంటర్నల్ రెసిస్టెన్స్ స్మాల్ r అని భావిస్తే better you can say here Rn is equal small r. Then IA into R is equal to instead of output voltage V naught by A అనొచ్చా. ఇక్కడ నుంచి IA is equal to V naught by A into R అనొచ్చా. ఇదండి గెయిన్ గా నెగటివ్ వస్తుంది, నెగటివ్ ఫీడ్బ్యాక్ తీసుకున్నప్పుడు మైనస్ సైన్ వస్తుంది. ఈ రఫ్ వర్క్ నుంచి నేను బ్లైండ్ గా రాయొచ్చు ఇక్కడ నేను, బట్ యూ కెన్ సే బట్ IA ఈజ్ ఈక్వల్ టు ఇక్కడ చేసిన వర్క్ అంతా రఫ్ వర్క్ IA ఈజ్ ఈక్వల్ టు మైనస్ V naught by A ఇంటూ R. దీని I in ఒక ఈక్వేషన్ నెంబర్ R అందాం, ఇది ఇక్కడ ఈక్వేషన్ నెంబర్ 7, ఇది ఈక్వేషన్ నెంబర్ 8. Equation number 6, 7, 8 you can substitute in equation number 5. అప్పుడు ఏమొస్తుంది చూద్దాం. ఈ పార్ట్ అప్ చేసుకోవచ్చా అప్ టు ఈక్వేషన్ నెంబర్ 4. అబ్జర్వ్ కేర్ఫుల్లీ. Equation 6, 7, 8 substituting in equation 5. Equation 6, 7 and 8 substitute in equation 5. That implies I in value V in plus V naught by A divided by R in. Okay, this is nothing but a smaller అనుకోవచ్చా, equal to IA minus V naught by A into R plus IF మైనస్ కామన్ తీసుకోవచ్చా, మైనస్ V naught కూడా కామన్ తీసుకుంటే 1 plus 1 by A వస్తుంది అక్కడ డివైడెడ్ బై ZF feedback impedance. Now you can find out here relation in terms of V naught and V in. You can split the part, you can send other side, and దీన్ని ఇక్కడ పార్ట్ గా డివైడ్ చేస్తే V in by R డివైడ్ బై R వస్తుంది. ఇప్పుడు V naught అంతా ఒకసారి కామన్ తీయొచ్చా, V in by small r is equal to minus V naught కామన్ తీస్తే మైనస్ V naught కామన్ తీస్తే ఏమొస్తుంది, ఇది అటు వెళ్ళిపోతుంది. ఇది క్యాన్సిల్ అవుతుందా, నో, మైనస్ 2V naught by AR వస్తుందా. అబ్జర్వ్ కేర్ఫుల్లీ. ఇది R కి తీసుకోకుండా R in ని ఇంపిడెన్స్ రెసిస్టెన్స్ కి తీసుకుందాం. దీన్ని Z in అందాం, ఇంపిడెంట్ రెసిస్టెన్స్ కాంబినేషన్ ఆఫ్ ద 2 టర్మినల్స్. అప్పుడు వాల్యూ ఇది క్యాన్సిల్ అవ్వదు, లేదంటే R తీసుకుంటే ఇది క్యాన్సిల్ అయిపోతుంది. then you can say 2 times, not cancel, 2 times అవుతుంది. సో V in by Z in ఈక్వల్ టు మైనస్ V naught కామన్ తీస్తే V naught కామన్ తీస్తే 1 by AR అటు వెళ్తే కూడా ప్లస్ V naught కామన్ వెళ్ళిపోయింది 1 by A into Z in ప్లస్ 1 plus 1 by A divided by ZF. ఓకేనా. ఇప్పుడు మనం తీసుకున్న V naught by V in వచ్చేలా చూద్దాం, అవుట్పుట్ వోల్టేజ్ బై ఇన్పుట్. దెన్ ఐ విల్ గెట్ అగైన్ ఓన్లీ PG first year MSc Physics-Course for Semiconductor Devices Analog Digital System meeting ID. Okay. రైట్. V out by V in is equal to, will get gain లాగా వస్తుంది కాబట్టి V out by V in equal to రాసినట్టు అతను ఇక్కడ. From this we can say V out by V in cross multiplication. V out by V in is equal cross multiplication something వస్తుంది. ఇది ఇటు నుంచి ఇది ఇట్లా లాగేస్తే ఇది ఇటు వస్తుంది, రాస్తే డివైడ్ అవుతుందా 1 by Z in into 1 plus my bad Z in into 1 by ఈ మొత్తానికి డివైడ్ వస్తుంది కదా 1 by AR plus 1 by A into Z in ఇది కూడా ఇలా లాగేస్తే ఏమవుతుంది అప్పుడు A 1 plus A డివైడెడ్ బై ఇక్కడ ఎల్సిఎం ఏ తీస్తున్నాను అప్పుడు వస్తుంది 1 ప్లస్ ఏనా అక్కడ A ప్లస్ 1 బై ZF వస్తుంది A ఇంటూ ZF కొద్దిగా జాగ్రత్తగా అబ్జర్వ్ చేయండి ZF ఈ పార్ట్ని స్ప్లిట్ చేస్తే ఏమవుతుంది అప్పుడు ఇది 1 by A ఇంటూ ZF ప్లస్ 1 by ZF దీన్ని స్ప్లిట్ చేస్తే సారీ ఇది ఇక్కడనే స్ప్లిట్ చేయొచ్చు కదా 1 by ZF ప్లస్ 1 by A ఇంటూ ZF ఇక్కడ ZF ని కామన్ తీస్తే ఇక్కడ వస్తుంది ZF ని కామన్ తీస్తే V0 by V in ఇక్కడ మైనస్ ఉంది V0 by V in is equal to 1 by Z in ఇక్కడ డినామినేటర్ లో ZF నే కామన్ తీస్తాను ZF అప్పుడు ఏమొస్తుంది ఇక్కడ ZF by AR ప్లస్ 1 by A ఇంటూ ZF by Z in ప్లస్ ZF by ZF by ZF అంటే 1 అవుతుంది 1 ఇక్కడ 1 by A ఇక్కడ 1 by A కామన్ తీసుకోవచ్చు ఈ ZF పైకి వెళ్ళిపోతే వస్తుంది మళ్ళీ మైనస్ V0 by V in is equal to ZF by Z in ఇంటూ అంటే ఇది మొత్తం 1 by ఇక్కడ 1 by A కామన్ తీసుకుంటాను 1 ప్లస్ 1 by A 1 ప్లస్ 1 by A ఇంటూ 1 ప్లస్ 1 by A ఇక్కడ 1 by A కామన్ తీసుకుంటున్నా 1 సెకండ్ మిస్టేక్ వచ్చింది 1 ప్లస్ మై బ్యాడ్ ఇది 1 అట్లాగే ఇండివిజువల్ తీసుకుంటాను 1 1 ఇక్కడ ఈ రెండిట్లో 1 by A కామన్ తీసుకుంటే 1 by A ఇంటూ ZF ఇక్కడ కూడా 1 by A ఉంది కదా అంటే 1 2 3 టర్మ్స్ లో కూడా 1 by A కామన్ తీసుకుంటే అప్పుడు ఏమొస్తుంది మనకి మిగిలిన వాల్యూ 1 by A కామన్ తీసుకున్నాం కాబట్టి 1 ప్లస్ ZF by Z in ZF by Z in plus ZF by R. Check it properly. ZF by R. Is it okay? Or not? If this input resistance is very large, and it's zero number. If input resistance is large, look at properly here. If R is equal to large or very large, then we'll get something value here. ఈ మైనస్ అటు పంపించుకోవచ్చు కదా V0 by V in is equal to minus ZF by Z in into this whole thing divided by 1 by ఈ పార్ట్ 0 అయిపోతున్నప్పుడు 1 plus 1 by A into 1 plus ZF by Zin. 1 plus ZF by Zin. Next, we can take it as feedback gain. The feedback gain that is beta is equal to input resistance impedance. Beta is equal to Zin by ZF plus Zin. Zin by ZF plus Zin. From that, you can express beta is equal to this in terms of impedance. If in case of in terms of resistance, Rin by Rf plus Rin. Also same thing, same meaning on. So we can express here V out by V in nothing but beta only, gain, voltage gain. So it can be written as, so from this equation, V naught by V in nothing but beta, ZF by Z in minus ZF by Z in, then whole thing into దాన్ని ZF by Z in ని మార్చగలుగుతామా? 1 second, we'll try to change. 1 by 1 plus 1 by beta A. So from that, we have to change. From that equation, we have to get ZF by Zin is equal to, we have to get here 1 by 1 plus 1 by beta A. ఈ టర్మ్స్ ని ఎలిమినేట్ చేసి ఇది రావట్టగల. దిస్ ద ఫైనల్ స్టెప్. Is it possible? 1 by 1 plus 1 as it is only. 1 also same thing only. Instead of 1 by A into 1 plus Z by Zin is equal to 1 by A beta or beta A. So from that, beta is equal to Zi by or Zin by ZF plus Zn అని రాస్తే ఎలిమినేషన్ చేయగలుగుతాం అక్కడ నుంచి. Check it once. Check that step. Okay. Next, similarly, same story for non-inverting operational amplifier. This is for inverting operational amplifier purpose. Same thing for non-inverting operational amplifiers. Understood? This thing is a inverting operational amplifier configuration. Similarly, you can find out non-inverting configuration. Non-inverting configuration characteristics also. For that one, you'll get final equation almost same only. After that, inverting configuration, non-inverting configuration. Inverting configuration, non-inverting configuration differences for 5 marks. But you can expect 10 markers inverting configuration, operational amplifier configuration, non-inverting operational amplifier configuration. From these two, maximum cases it can repeat it. Is it okay? Okay, na? Yes. One, check this derivation part. The next, similarly, you can practice yourself non-inverting configuration. Then you can go theory points from the material only. Inverting configuration, non-inverting configuration differences. Note on these points from board. Then in the next class, operational amplified frequency. That is a very important. Open loop frequency response, closed loop frequency response. I mean, damn sure questions are unit law. Stability of operational amplifier. 90% ఓపెన్ లూప్ ఆర్ క్లోజ్డ్ లూప్ లో వస్తుంది, అది మిస్ అయితే స్టెబిలిటీ వస్తుంది. ఇక్కడ అడిగితే ఇది 5 మార్క్స్ అడిగితే అడగచ్చు. నెక్స్ట్ 10 మార్క్స్ లో కానీ 5 మార్క్స్ లో కానీ ఓపెన్ లూప్, క్లోజ్డ్ లూప్, frequency response is a very important. That thing we'll see in the further class. If possible, we can try to finish in tomorrow class rest of 4 units. 4 units mostly కాకపోవచ్చు, 3 units వరకు వెళ్ళొచ్చు. We'll see possible అయినంత మటుకి. 10, 11, 12, 13. These 4 units we'll try to finish if possible tomorrow or else in the next weekend. Officially, we have 3 more classes tomorrow and next Saturday and Sunday. In that 3 days, I'll try to finish in 1.5 class the second block. Then next, I'll go to back 1.5 class in the first unit theory part explanation part. Semiconductor devices. P-N junction diode, transistors, that characteristics parts are there, configurations, different modes of configurations. That configuration parts, again I'll explain the next classes. My plan, I'm going to approaching here. We have 3 more classes. In that 3 more classes, at least 1 or to 1.5 class, we can try to finish this second block 4 units. Next 1 or 1.5 class, we'll try to discuss major parts in unit 1. Then officially classes will be over from university. So before that, you can pre-plan for upcoming exam purpose. Next month only exam. Hardly next month 9th onwards na. 9, 10, 11, 12, 13 and so on. 4 days for our science people, math people's 5 days. Okay. Then we can try to revise yourself non-inverting configuration explanation part. At the same time, difference between inverting and non-inverting operational amplifier configurations. The next I'll start in the tomorrow class, same time, unit 10 onwards. Open loop frequency response, closed loop frequency response onwards. I'll discuss in the next class. Means tomorrow on. Is it okay? So I'm stopping here only today. If any doubts or any queries, you can respond in the chat box. Otherwise, we can stop our class here only. Is it okay? Okay. Motorola Edge 50 Fusion. Thank you. The next anybody? If any doubts from your side, you can chat in the chat box, or else you can speak one by one. Thank you, Xiaomi. The next. If any doubts in the previous units or this unit's examination point of view, already I sent few selected questions in the WhatsApp group only now. First priority, you can try to read yourself that selected questions only enough. That questions are there or not in the previous year questions, you can check. Okay, now? Then I'm closing here only my class. Thank you. Bye. Hello, 1 second. It was okay. Is it okay? Yes. Thank you. Bye. We can leave class here only. No one sent any messages. That's why I'm closing meeting here only. We'll meet tomorrow.